All right, welcome back everyone. How you guys doing? All right, so we are today going to be looking at just finishing up this review of acids and bases, and we are going to be just preparing for this upcoming test. All right, so guys, just say hi to me in the comment section in the chat right over there, and just to see who's here, all that kind of stuff. Now, last time I had talked about how we could do this test either Tuesday or Wednesday. I didn't hear anybody that said they wanted it Tuesday. I heard 2 people that said they wanted it Wednesday. So we're going to go ahead and move it to Wednesday unless somebody right now says, no, we need to have it Tuesday because of such and such a reason. All right. So I think a lot of people just didn't care. It didn't make really much of a difference. But I think the plan right now is our test is going to be Wednesday. And then, yes, I'm seeing, oh, this is a third person to say Wednesday. So the test is going to be Wednesday. And then what we're going to do is tomorrow, we're not going to have a live stream. I'm not going to give you guys new homework. But if you guys want, I can just have office hours. I can, have a little, Zoom meeting if you guys want, or you guys could just, whenever you have questions, you could just email me and I could discuss it through email, and that works fine too. So whatever you guys want to do tomorrow, we can do that, but I don't have anything that I need to cover tomorrow. And so we're just going to go through these problems today, and that's going to be it. All right. So again, if you guys want to do something specific tomorrow, just tell me. Otherwise, tomorrow is just going to be a free day to review, all that kind of stuff. All right. So with that said, let's go ahead and just go through these problems. I'm going to try to go through them kind of slowly. And if you guys have any questions, just stop, because this review is going to tell you what's going to be on the test. So make sure you guys know this stuff. All right. All right. So first, let's go to number 3. All right. Because we already talked about some of this other stuff. Let's go to number 3 and say, okay, what is this conjugate acid, conjugate base stuff? All right. Conjugate acid, a conjugate acid, to get a conjugate acid of anything, we're going to add H plus to get a conjugate acid. To get the conjugate base of something, we're going to remove H plus. Okay? And you can see that we've done that here already. So let's look at H2SO4, which is sulfuric acid. If I add H plus to it, I'll make its conjugate acid. And adding H plus necessarily means we add an H, so that's going to be H3SO4. But we're not just adding H, we're adding H plus, so this should be H3SO4 plus. Okay? The conjugate base would be to remove an H plus from it. And so if we start off with H2SO4 and we remove H+, it then becomes, it has only one H. So H2 goes down to HSO4. And if we're removing H+, the charge now becomes negative, right? Next, HSO4 minus, right, which is this thing, HSO4 minus, the conjugate acid of HSO4 minus would be to add an H plus. So that's going to go back to H2SO4. We're adding an H to this. And we're adding H plus, so the minus, so minus 1 plus plus 1 is 0. So there's no charge in H2SO4. Then the conjugate base of HSO4 minus would be to remove an H plus from that. So that's going to be SO4, taking away this H, and if we're removing a plus from minus 1, that's going to give this a 2 minus charge, SO4 2 minus. So for the conjugate base, you're always going to be subtracting 1 from the charge. For the conjugate acid, we're always going to be adding 1 to the charge. All right, questions on those? Anything? We got 6 people, so hey, it's okay. Everybody else still asleep, going to watch this later, I suppose. Maybe they'll be pleasantly surprised that the test has been moved to Wednesday, or maybe they'll be upset. But either way, because they're not here during class, they don't get a say. All right. Any questions at all? We're good? We're good? Cool. All right. And Connor, like always here in class, so that's cool. So thank you guys. I appreciate it that you guys are always here. I don't know who else is here. We'll see. Don't know. Lupita is often here too. I don't know. Oh yeah, she's there. I see her all the way at the beginning. So you three are like my 3 people that always come to class. The 4 other people here, don't know who they are. All right. Number 5, ammonia is a weak base. How could you make it make a buffer from it? So a buffer, we recall that a buffer is made by taking a weak acid or a weak base and adding its conjugate acid or base. So if you have an acid, we're going to add the conjugate base. If you have a base, what we're going to do is we want to add its conjugate acid. Okay? But it's important that this is first of all, it's important that this is a weak base. And we also are going to add the conjugate acid to it. Now, what in the world is the conjugate acid of this? Well, the conjugate acid of anything is when we add H plus to it. So we're going to not just add any conjugate acid, but we're going to add NH4 plus to it. Okay? And this is kind of the answer that I'm looking for, right? And if you want to be even fancier, you can recognize, well, you can't just add NH4 plus. There's always got to be a counter ion. So you could also say we add NH4Cl or something like that. And that's perfectly correct. That's great, right? And ammonium chloride, NH4 plus. That's going to be one way. Well, how do you add NH4 plus? By adding, let's say, ammonium chloride. Okay? So that's a buffer and that's a buffer. Both of those are buffers. Any questions on, oh, look, Sarah's here too. Awesome. Nice. Any question on any of these buffer things? You'll probably have, let's say, one question on your test about buffers, which is going to probably be like, let's say, number 4 or 5, which you need to be able to know how to get a conjugate acid or base. And you need to recognize, well, if it's a weak base, you add the conjugate acid. If it's a weak acid, you add the conjugate base. Cool? You took the H right away. Oh, you took the H away. Oh, sorry, I read that wrong. You took the H away, right? Yes, I took the, where? No. I didn't take an H away. I added an H. But if you mean up here for number 4, I took the H away. For number 5, I added an H, right? And it's important that we're always adding it as, for number 4. It's important that we're noticing that we're always adding or removing H as H plus. So yes, in number 4, all I did was I took this H away and I gave it a negative charge. So I'm removing an H plus to get the conjugate base of this acetic acid. Okay? So yeah, that's what I did in number 4, Connor. Cool. All right. Down to number 6. And hopefully this is going to be easy for us. I'm hoping. All right, but you're going to get a question like this on the test too. Classify each of the following as acids, bases, or neither according to the Arrhenius definition. What we're doing is we're looking at that first thing. Is the first thing an H? If the first thing is an H, then that thing is going to be an acid according to Arrhenius, right? So this is an acid. This first thing is an H, so this is an acid, right? This first thing's not an H. This first thing is an H, so this is an acid. And this first thing is an H, so you're thinking, oh, this must be an acid too, but it's not, because we know that H2O is just water. And so this is going to be neither. All right? So we look at that first thing and see if there's an H in front. According to Arrhenius, if there's an H in front, it's an acid, unless it's water. In that case, it's going to be neither. So let's come back over here, and we look at this one. This is not an acid, but is it a base? This is going to be sodium chlorate. Sodium chlorate. Well, sodium chlorate does not have OH in it. It's not sodium hydroxide. And so according to Arrhenius, it's not going to be a base. Okay? According to Bronsted and Lowry, it could be a base, maybe. But according to Arrhenius, it's not a base because there's no OH. So this is going to be neither. All right? And then rubidium hydroxide, you can hear it right in the name, or you can see it right there. That OH excuse me, that OH is a hydroxide, and so this is going to be a base. All right, so that's Arrhenius, straightforward. Just look at the formula. You can tell whether it's an acid or base. Any questions on that? You will definitely have a question like this in the test. Okay? All right. Next up, next page, let's get to it. Oh, where is it? Next page is right over here. Oh, here we go. And this is a kind of an open-ended question. I'm going to try to avoid any kind of open-ended questions on the test. So on the test, it will look more like, you know, is this particular thing monoprotic, diprotic, triprotic, or what? Okay? But because this is a review, I decided to leave this open-ended. Monoprotic, you could list a whole bunch of different things. Okay? So monoprotic acid might be like HNO3, nitric acid. Why? Because there's only one H. Diprotic, there's not a whole lot of these, but H2SO4. Sulfuric acid is a diprotic acid because there's two H's. And then triprotic acid, there's even fewer of these, H3PO4. That's a triprotic acid because there's three H's. All right. And if you want to go a step further and say, okay, which of these are polyprotic? Well, both of these are polyprotic. Polyprotic means that there's more than one H. This has more than one H, and this has more than one H. So both of these are polyprotic. This is diprotic, and that's triprotic. All right. Like I said, many different correct answers for this one. Okay? All right, number 8. We're going to label these acid, base, conjugate acid, conjugate base. This is where it might start to get tricky, guys. So you got to pay attention. And here we got a question. Would H3SO4 be diprotic? Well, H3SO4 doesn't really exist. But if it did, let's suppose that existed. All right? H3SO4 would be triprotic because there's three H's. But like I said, that doesn't actually exist. Okay? But it's like I said, you're not going to have to come up with these. It's going to be not an open-ended question, but a, you know, is this thing monoprotic, diprotic, and triprotic? And literally all you do is you count the H's in front. Okay? It can be a little tricky when you deal with things like, let's do it, like acetic acid, okay, or organic acids. And I'm going to try, I think I'm going to try to avoid giving you a tricky question like this. But notice, if you have something like acetic acid, you have literally 4 hydrogens in that compound. But acetic acid is a monoprotic acid. It's monoprotic. Why is it monoprotic? It's monoprotic because there's only one H in front. Okay? And so it's only the H's in front that are acidic. And so acetic acid is monoprotic. And you have things like this. This is diprotic, right? This one right here is diprotic because there's 2 H's. That is oxalic acid, I believe, right? This is diprotic, right? Because you have 2 H's in front, although it's fairly weak in terms of its acidity. All right, but you're just counting the H's in front, okay? So, triprotic, mono, di, tri. There we go. I mean, I'm not going to have you guys come up with some. I'm just going to have you, just label them. I think that's, just makes it more straightforward for me. Anyway, number 8. Let's label these acid, base, all that kind of stuff. Now, it's tricky because when we look at this, actually, the second one's going to be easier. The first one's going to be harder. When we look at the first one, we notice this is an acid according to Arrhenius, and this is an acid according to Arrhenius. So, we can't just label them as acid and acid. They're reacting with each other, so one of them's the acid and one of them's the base. The acid is the one that loses an H. So we look over here and see which one lost an H. Well, clearly this one is the one that lost an H because there's no H there. And so we find it over here. Here it has an H, here it doesn't. So this one must be the acid. That is your acid because this is the one that's losing an H. Over here it has lost the H, and so this must be its conjugate base. So I would identify your conjugate base before you even identify your base. Why? Because once you start identifying your base, you're going to lose track of what you just did. Identify your acid, find out what it turned into, which thing lost an H, right? Here, it's this thing that lost the H, and then you must say, okay, that's your acid conjugate base pair, right? Because this is the thing that has, after the acid loses an H, it turns into the conjugate base, okay? Once you've done that, then everything else is easy, right? Then you don't even need to think about it at this time, because this one must be your base, and this one must be your conjugate acid, right? And you can verify it by saying, okay, the base is the thing that receives an H+, so here it is with 3 H's, here it is with 4 H's, so this must be your conjugate acid. And that's correct. Okay? All right. So expect something tricky like that. That is perfectly legitimate to find on the test. Let's get on to the next one. The next one seems a little bit easier, at least in my opinion, because you have here something that looks like an acid and something that doesn't look like an acid. Let's see if I'm correct. Here's the thing that looks like an acid, and it turns into, well, yeah, it's losing 2 H's. So here, this is going to be your acid, and we follow the SO4 over here, and it has lost 2 H's. So this is going to be your conjugate base. Technically speaking, this is the conjugate base of the conjugate base, but we're just going to label it as conjugate base for this reaction, which is fine. And that means the other thing must be your base. And let's verify the base is the thing that receives an H+, and here it's got 3 H's, here it's got 4 H's. Yes, indeed, it's got more H's here. So this is your base, and this must be your conjugate acid. Okay? All right. And so that's number 8. So you're going to see something like that on the test too. Any questions on number 8? All right. Number 9, pH calculations. You're going to have to do maybe some easy pH calculations and some like a hard pH calculation question down number 12. Okay. So pH calculations for both acids and bases. Make sure you recognize whether it's an acid or a base. Let's do that first, right? HCl, that's an acid, and because it's an acid, the pH is going to be equal to negative log of your molarity, right? Of your H+ molarity, so negative log of 9, so you get your answer. This also is an acid because there's an H in front, so your pH is going to be negative log of 0.0044. This, however, is a base because it's a hydroxide, right? And so your pH is going to be 14 plus the log of your OH minus molarity. And that's going to be a log of 0.00075. All right, let's go ahead and plug them in, get the actual numbers. Okay, so negative log. Very important that you can do this in your calculator. Don't just watch this video. Make sure that you can actually calculate it yourself. If you can't, no one's going to be around to help you out during the test, right? No one's going to be like, oh, this is how you use your calculator, Johnny. No, sorry, Johnny. Use your calculator ahead of time and figure out how to use your calculator before the test. So anyway, negative log of 9, enter. And that's a negative pH. Crazy. Is it possible to have a negative pH, Mr. Katz? Yes, it is. And this, in fact, is going to be correct. This is negative 0.995. Let's just round it off to 0.95. We have 2 sig figs here, and so we should have 2 numbers after the decimal point. All right? Negative pH means we have a very acidic solution, very, very acidic solution, okay? And that is most certainly possible when we have concentrated strong acids, and here we do, 9 mole per liter, that's pretty concentrated. And so yes, that's correct, all right? So negative 0.95 as our pH for that one, no problem for that. Next up, let's do negative log of 0.0044. All right. And that's going to give me 2.36, 2.36, so round it up to 2.36, okay? If I have two significant figures here, I should have two numbers after the decimal point. Two numbers after the decimal point. Do not round this off to 2, okay? It must be 2.36, or I suppose I would give credit to 2.4. But if you wrote a pH of 2, you would get this number wrong, because you cannot round it off to simply the whole digit or a whole number. All right, last of all, we have this one, 14 plus the log of 0.00075. All right, that's going to give us 10.88. So I'm going to round that 5, causes the 7 to round up, the 5 causes the 7 to round up to an 8. So it's 10.88. 10.88. Once again, if you wrote 11, you would be wrong, okay? So we have two significant figures here, so we need to have two numbers after the decimal point. That's where we're going to round to 10.88. All right, so that's your pH calculations. And I also want you guys to know about pH in general. How many times more acidic is pH of 3 than a pH of 6? And, excuse me, there's two ways that we could do this. And that is, let's start with pH equals 6, pH equals 5, pH equals 4, pH equals 3, okay? So pH equals 6 is the same as pH equals 6. pH equals 5 is 10 times more acidic. pH equals 4 is 10 times as acidic as 5, so this is going to be 100 times. pH of 3 is going to be 10 times as much as 4, or 1,000 times as acidic as pH 6. So the answer is 1,000 times, all right? Don't be tricked on this, okay? So you can do it this way, or you could do it this way. You could do 10 to the power of 6 minus 3. We are comparing 6 and 3, so it's 10 to the power of 6 minus 3, which equals 10 to the third, which equals 1,000. Either way, whether you like the mathy way or you like the more conceptual way, make sure that you can answer a question like this. You will see one on the test. Okay? Next. And this works for bases too, right? So let's suppose we're comparing, let's just throw something down out here. All right, let's suppose you're comparing pH of 13 with a pH of 12. Well, which one's more basic? Well, 13 is more basic. All right, and how many times more basic? 13 is 10 times more basic than a pH of 12. All right, pH of 14 is 100 times more basic than a pH of 12. And so it works the same way with bases. Okay? All right. Number 11, write out the balanced complete neutralization reaction. Sorry about this. I think I've run into my space here, but let's see if it works. We have a straightforward acid with an H in front and base with an OH minus, and so we know that we're going to make water, H2O, right? H plus and OH minus makes H2O. Now the question is how many? And we can look here and look here. If there's more than one hydroxide, that's going to make more than one waters. If there's more than one H plus, we're going to make more than one waters. So we have 3 H pluses, so I'm going to make 3 H2O, which means I need to balance that right here by putting a 3 right there in front of lithium hydroxide, right? I need 3 hydroxides for every 3 H pluses, so I'm going to make 3 waters, and what's left? What's left is 3 lithiums and 1 phosphate. So that's going to be Li3PO4. That is my balanced reaction. Okay? Hopefully you guys got that. The 3 here is critical, and the 3 here is also very important. The other way that you know that this is Li3PO4 is the fact that, let's see, where can I write this? The fact that lithium, we know, is a +1 charge based on the fact that it's an alkali metals in the first column, and phosphate, we've memorized ages ago, has a 3- charge. So +1 and 3- makes Li3PO4. Okay? All right, number 12. Let's do that one. That looks like triflic acid. Okay, so here we go. Triflic acid. You guys, who knows whether you'll ever hear that again in your life. But that's a very, very strong acid. That's stronger than hydrochloric acid. It's stronger than sulfuric acid. Very, very strong acid. So triflic acid is strong acid. And we're going to dissolve that in water. And we want to know what's the pH. So what we have to do is a multi-step process. And the first step is that we need to calculate the molar mass of this, right? Molar mass. Okay? Because you're probably, on the test, you're probably going to get something that you've never seen before. So that I can see that you're actually calculating the molar mass. All right? So we got triflic acid, and we want to know the molar mass of HSO3CF3, which is a bit annoying, I know. I'm sorry. But we have 1H, right? 1H from, here we go. 1H, so that's going to be 1.0079. Plus we have 1 sulfur. Sulfur is right over here. That's going to be 32.00. No, sorry, 32.066. Plus we have 3 oxygens. So this is going to be 3 times 15.999. Plus we have 1 carbon. That's going to be 12.011. And we have 3 fluorines. All right, that's going to be 3 times 18.998. What's that get us? It gets about 150. So 150.76, something like that. All right, so my molar mass, 150.076 grams per mole. All right, now, after that, what do we need to do? We need to convert this mass into moles, and then we need to convert that moles into molarity, and finally calculate the pH. Really, it's really like a 4-step process here. Okay, so here's your step 1. Let's go ahead and let's do green here. My step 2 is we're going to convert this grams, 0.907 grams of this to moles. And if we're starting with grams, we need to make sure that our 150 grams goes in the bottom. We want to convert it to moles. So moles, 1 mole goes in the top. And let's just do that right now. Okay, 0.907 divided by my previous answer, and that's going to give me 0.006. 0.00604 moles. The third step, step number 3, and this is the step, guys, you who are actually watching this, okay? Because I know for a fact that somebody's going to make this mistake on the test, okay? But you guys watching this, you're not going to make this mistake, okay? Number 3 is the step that people skip all the time. They're like, oh, moles, and they get a number, and they want to do something with it, and so they right away they plug it into the pH equation. But that's wrong, okay? You have to first convert the moles into molarity. So step number 3 is we're going to calculate molarity is N over V. And that's going to be taking this 0.00604 moles, and we need to divide by the volume. Tricky one here, we need to make sure this volume right here is in liters. Okay, so we're going to take the decimal point, move it 1, 2, 3 spots to the left to get 0.0788 liters. So this is going to be divided by 0.0788 liters. So we just, in our calculator, I'm not going to retype this. All I do is hit divided by 0.0788, enter. Now that's my molarity. Almost done now. 0.0767 moles per liter. Finally, I can solve for the pH. And the pH, because this is an acid, it tells us it's an acid. Because it's an acid, the pH is the negative log of your acid molarity, or the negative log of 0.0767. And again, I am not going to type that in. I'm just going to use the number in my calculator. And so it's going to be negative log of that number. And boom, that's my answer. 1.115. I have 3 significant figures, so my final answer should be 1.115. 3 numbers after the decimal point. That's it. That's my answer. Okay? Now, on the test, you might have to calculate the pH of an acid, or you might have to calculate the pH of a base, either way. Okay? So, I'm not seeing any questions, which means I'm just going to go on to number 13. And you guys, you're welcome to stop me any place if you guys have any questions or anything. But let's go on. Again, you're going to have one question like number 12, one question like number 13. Your question like number 12, it might be an acid, might be a base. I don't know. All right, number 13, here we go. We're going to titrate something. When you titrate this thing, we are going to perfectly neutralize the moles of acid with the moles of base. We have an unknown base. And after we do the titration, well, we notice that it took 18.6 milliliters of this. This is our known stuff. So this is one of those weird problems where we start with the numbers at the end and then work backwards, okay? So we're going to start with these 2 numbers first, all right? And we're going to work backwards. And the reason that is for that is that these are our known amounts. And so I always take our milliliters and convert to liters first. So we're going to have, let me go ahead and write it out. So M equals N over V, and we want to calculate N. Why? Because if we want to figure out what the molar mass is, we need to have the moles of our unknown. In order to figure out moles of unknown, we need to have moles of our known, okay? So the whole goal is to get the moles. And so N equals Vm, okay? And so let's go ahead and write down the numbers. We have 0.0186 liters. Make sure you convert that to liters. And I'm multiplying this by, this is my molarity, which is 0.25 moles per liter. Notice liters over liters cancel to give me moles in the end. So let's do that. 186 times 0.25, which is 0.00465. 0.00465. Units are moles. All right, now this one's really only 2 steps. The second step is to calculate the molar mass. And it's an unknown, so we can't just look up on the periodic table. So the molar mass is going to be what? It's going to be the mass of the unknown over the moles of the unknown. And we remember, this is the moles of what? It's the moles of HCl, but it's also equal to the moles of the unknown. That's the beauty of titration. The 2 moles are equal, okay? So then we're going to do what? We're going to do the mass of the unknown, or 0.565 grams, divide by the moles of 0.00465 moles, and that'll be my final answer. 0.565 divided by that gets me 121.5. I have 3 sig figs, so let's round it up to 122. 122 grams per mole. That's my final answer. Okay? So that's all it. That's your review, and I think it's pretty indicative of what you might see on the test. Obviously, the chemicals and the numbers are going to be different, but the same kinds of ideas are going to be on your test. Any questions at all? Anything at all? Oh, look at this. We had 11 people on. Oh, that's so cute. All right, 11 people. All right, so test is going to be on Wednesday. We've got 3 votes for Wednesday, 0 votes for Tuesday. So we're going to make the test on Wednesday. No questions. If Connor has no questions, that means Connor's confident. Good job, Connor. And anybody else with questions, you're welcome. You're perfectly welcome. All right. So you know what? I'm gonna sign out. And on Tuesday, as you guys are doing any extra review, if you want to do any extra review, if you have any questions, just email me on Tuesday. Otherwise, Tuesday is going to be a day off. All right, you're welcome. It's going to be a day off, and then Wednesday is going to be the test day. All right, so see ya, and good luck.